Today we're live coding TikTok from scratch with 3 engineers who have actually worked on short video platforms. No textbook answers, no perfect solutions, just real engineering under pressure. I'm Sam, and we're about to discover why TikTok's algorithm is harder to build than Netflix's recommendation engine.
I spent 2 years optimizing TikTok's recommendation pipeline. The biggest misconception people have is that it's just collaborative filtering. Reality? We're processing 1 billion video views daily with sub 100 milliseconds recommendation latency. Traditional batch ML doesn't work at that scale.
I built video processing systems at 3 different startups trying to compete with TikTok. All failed. The technical challenges aren't obvious until you hit scale. 15-second videos uploaded by millions of users simultaneously, each needing 20-plus encoding formats, delivered globally with 0 buffering.
I've interviewed at TikTok twice, failed once. The system design question seems simple: build a short video platform. But the devil is in the details. How do you handle viral content that goes from 0 to 100 million views in 6 hours? How do you keep the algorithm fresh when user preferences change every few swipes?
Perfect, today's challenge. Design TikTok's core platform. Maya, you're our interviewer since you know their actual architecture. Jordan and Alex, your candidates. 1 hour, real constraints, brutal feedback.
All right, design TikTok. 1 billion daily active users, 15-second to 10-minute videos, global deployment. Your system needs to handle video upload, processing, storage, recommendation, and delivery. Start with requirements gathering, but don't spend forever on it. Go.
Okay, scale first. 1 billion DAU, let's assume 30% are actively uploading daily, that's 300 million uploads. If average video is 1 minute at 20 megabytes, that's 6 petabytes of raw upload data daily.
Wait, 20 megabytes for 1 minute is way too high for mobile uploads. Users are on cellular networks, more like 5 to 8 megabytes for a minute of compressed video. But we still need to encode multiple formats. That's the real storage killer.
Good point on mobile constraints. How many encoding formats do you think TikTok generates per video?
Maybe 5 to 10, different resolutions for different devices. 1080p, 720p, 480p.
Try 20 plus. Different codecs, H.264, H.265, different bitrates for adaptive streaming, different resolutions, different aspect ratios for different devices. Each upload becomes 20x larger after processing. Recalculate your storage needs.
Jesus, 6 petabytes becomes 120 petabytes daily. That's 44 exabytes per year just for new content, not counting existing library.
Now you're getting it. Storage is expensive, but bandwidth is the killer. When a video goes viral, say 100 million views in 6 hours, what happens to your CDN?
CDN caches would be overwhelmed. Need to pre-populate edge servers when you detect viral content early. But how do you predict that?
Exactly the right question. Design the architecture, start high level, then we'll drill into the viral content problem.
High-level, upload service, video processing pipeline, metadata storage, recommendation engine, CDN for delivery, user service, engagement tracking. Am I missing anything critical?
Content moderation. TikTok operates globally. Different countries have different content restrictions. How do you handle that at upload time versus post-processing?
Dual approach, automated screening during upload using computer vision and NLP to catch obvious violations. Then human review for edge cases, but that's expensive.
Smart. What happens when your automated system flags content incorrectly? User uploads a dance video, but AI thinks it's inappropriate because of the lighting.
Appeal process, but that takes time. Maybe release to limited audience first. Shadow ban until manual review confirms it's safe.
Shadow banning hurts virality. If a video could go viral but you limit its reach for 2 hours during manual review, you've killed its momentum. How do you balance safety with growth?
Confidence scores. High confidence safe content gets full distribution immediately. Medium confidence gets limited reach. Only low confidence gets held for review.
Good approach. Now let's talk about the recommendation engine. This is TikTok's secret sauce. What data do you collect to make recommendations?
Watch time, completion rate, likes, shares, comments, follows from the video. Users' historical interactions, device type, time of day.
What about implicit signals, things the user doesn't explicitly choose?
Scroll speed, how fast they swipe past videos, if they slow down or rewatch sections. Audio volume, if they turn sound on or off for specific content types.
Excellent. Also facial expressions via front camera, device orientation changes, even typing speed in comments. But here's the hard part. How do you process this data in real time? User swipes, you have 100 milliseconds to show the next video.
Pre-computed recommendations. Generate a queue of potential next videos for each user, update it periodically.
How long is your queue? User behavior changes every few swipes. If you pre-compute 100 videos but their preferences shift after watching 10, your queue is stale.
Shorter queue, maybe 10 to 20 videos ahead. Continuously regenerate based on recent interactions. Use streaming ML to update user embeddings in real time.
Now you're thinking like TikTok, but streaming ML at billion user scale is hard. How do you handle the technical implementation?
Apache Kafka for event streaming, Apache Flink for real-time processing. Every user interaction gets published to Kafka. Flink processes streams to update user profiles and trigger recommendation updates.
Good tech choices, but what's your partitioning strategy for Kafka? 1 billion users generating events every few seconds.
Partition by user ID. Keep all events for a user in the same partition to maintain order, then you can process events sequentially per user.
What if some users are way more active than others? Celebrity accounts generating millions of interactions while casual users generate dozens.
Hot partition problem. Maybe hash user ID but also consider activity level, or separate high-volume users into dedicated partitions.
Complex but necessary. Now the ML side, how do you train recommendation models when user preferences change so quickly?
Continuous learning. Instead of batch training daily, update models incrementally as new data comes in.
TikTok actually uses something called Monolith, a custom online learning framework. Instead of separate models for different tasks, one unified model that learns from all interactions simultaneously. Anyone heard of it?
No, but that sounds like it would avoid the feature drift problems you get with separate models. If click prediction and watch time prediction models diverge, recommendations get weird.
Exactly, single model, online training, real-time feature updates. But the engineering complexity is insane. Let's talk about video delivery. How do you handle the For You page infinite scroll of videos?
Pre-buffer the next few videos while current video is playing. Download in background so they're ready when user swipes.
How much do you pre-buffer? Mobile users are on limited data plans.
Adaptive based on network conditions. On Wi-Fi, maybe buffer 5 to 10 videos ahead. On cellular, just 2 to 3. Also start with lower quality and upgrade if user engages.
Smart, but what about video startup time? User swipes, how fast does the next video need to start playing?
Sub-second, maybe 200 to 300 milliseconds max. Any longer and the user experience feels laggy.
TikTok targets under 200 milliseconds globally. How do you achieve that with a 15-second video that might be stored thousands of miles away?
Aggressive CDN caching, but you can't cache everything everywhere. Maybe predict what users will want to watch next and pre-position content at edge servers.
How do you predict what to pre-position? You can't put every video on every edge server. Storage costs would be insane.
ML-driven cache management. Predict what videos are likely to be requested in each geographic region, pre-populate those. Evict based on predicted demand decay.
Good thinking. Now the hardest problem, viral content. Video gets 1,000 views in first hour, then suddenly explodes to 10 million views in the next hour. Your CDN isn't prepared. What happens?
CDN origins get overwhelmed. Users start seeing buffering, complaints spike, video momentum dies. You need early viral detection and rapid cache propagation.
How do you detect viral content early? What signals indicate a video is about to explode?
Velocity metrics, views per minute, share rate, acceleration, comment velocity. If a video's engagement rate is way above its predicted baseline.
Also cross-platform signals. If people start sharing TikTok URLs on Twitter or Instagram, that's often early viral indicator. Social media APIs could feed into the detection system.
Excellent insights. Once you detect viral content, how fast can you propagate it to global CDN edges?
Depends on video size and CDN architecture. For a 15-second video at multiple bitrates, maybe 5 to 10 minutes to hit major global edges.
Too slow, viral content peaks in minutes, not hours. TikTok uses intelligent segment caching. They break videos into 2 to 3 second chunks and cache just the first chunk everywhere. Subsequent chunks get cached on demand.
Clever, so every video starts instantly because the first chunk is always cached, but you're not wasting storage on content that doesn't get watched to completion.
Exactly. Now let's talk about database architecture. How do you store user profiles, video metadata, and interaction data at TikTok scale?
Multi-tier approach, user profiles in relational DB like PostgreSQL, sharded by user ID. Video metadata in document store like MongoDB. Interaction data in time series DB like or Cassandra.
Reasonable, but what about hot users? Celebrities with 100 million followers getting millions of interactions per day.
Their data becomes a hot shard, maybe dedicated infrastructure for celebrity accounts, or read replicas specifically for high follower accounts.
Good direction. TikTok actually has separate infrastructure tiers based on account popularity, different SLA guarantees for different user classes. Now let's get into the nitty-gritty of video processing. User uploads a raw 60-second 4K video from their iPhone. Walk me through what happens.
Upload gets distributed across multiple data centers for redundancy. Then video enters processing pipeline format validation, malware scan, content moderation pass, then transcoding into multiple formats and resolutions.
How long does transcoding take for a 60-second video into 20-plus formats?
Depends on hardware, but probably 10 to 30 minutes on traditional CPU-based encoding. That's too slow for user experience. People expect their videos to be live within minutes.
Right, how do you speed it up?
Parallel processing. Split the video into segments, encode each segment separately on different machines, then concatenate results.
Also, GPU acceleration. Modern GPUs can encode video much faster than CPUs. NVIDIA's hardware encoders AWS GPU instances.
Both correct. TikTok uses distributed GPU clusters for encoding, but there's another optimization. They don't encode all formats immediately. What would you prioritize?
Encode the most common formats first. Maybe 1080p H.264 for mobile, then fill in other formats as background jobs.
Smart, they also use AI to predict which formats will be needed. If the video content suggests it's likely to be watched on desktop, prioritize higher resolutions. If it's a dance video likely to be shared on mobile, prioritize mobile formats.
That's incredibly sophisticated. But what about storage costs? You're generating 20x more data than the original upload.
Huge problem. How would you optimize storage costs for videos that might never be watched?
Tiered storage, keep popular content on fast SSDs, move unpopular content to cheaper storage. Eventually archive or delete content that's never accessed.
Good start. TikTok actually does predictive encoding deletion. If a video gets low engagement in its first 24 hours, they delete some of the less used format variants. They can always re-encode if needed later, but usually it's not.
That's brilliant cost optimization. But what about the social features? Comments, likes, shares, how do you handle real-time interactions at scale?
Great question. A viral video might get 10,000 comments in an hour. How do you display them in real time to all viewers?
WebSocket connections for real-time updates, but that's expensive for millions of concurrent users. Maybe polling for less active videos, WebSockets only for viral content.
How do you decide when to switch from polling to WebSockets?
Interaction velocity thresholds. If comments per minute exceeds some threshold, upgrade that video's viewers to real-time connections.
Solid approach, but there's another problem: comment ordering and moderation. How do you handle inappropriate comments in real time?
Automated filtering for obvious violations, profanity, spam patterns, harmful content. Shadow ban suspicious comments until human review.
What about different moderation standards in different countries? Content legal in the US might be illegal in Germany or Singapore.
Geo-based moderation rules. Comments get filtered through country-specific rule sets based on viewer location.
Correct but complex. Same comment might be visible to US users but hidden from EU users due to GDPR or content laws. Let's talk about the mobile app architecture. How do you handle offline usage?
Cache downloaded videos on device for offline viewing, but mobile storage is limited, so you need smart cache management.
How much do you cache? User has 64 gigabytes phone with 10 gigabytes free space.
Maybe 1 to 2 gigabytes max for video cache. Prioritize recently watched content and predicted next videos. LRU eviction for old content.
What about user-generated content? They record a video but lose internet connection before uploading.
Queue uploads locally, retry with exponential backoff when connection returns. Maybe compress video more aggressively for cellular uploads to save bandwidth.
Goods, now performance monitoring. How do you detect when your recommendation engine is performing poorly?
Engagement metrics dropping, average watch time decreasing, fewer likes and shares per video. Also technical metrics like recommendation latency, cache hit rates.
What if engagement drops in just one geographic region? Could be a localized content issue, or it could be infrastructure problems.
Regional dashboards, automatic alerting when metrics deviate from baselines. Correlation analysis between engagement drops and infrastructure issues, CDN performance, database latency, etc.
Excellent. Last question. How do you A/B test recommendation algorithms when every user's feed is unique?
User-level randomization. Assign users to different algorithm variants, compare engagement metrics across groups.
What's the contamination problem with recommendation A/B tests?
If algorithm A shows a video to group A, and they engage with it heavily, That affects the overall popularity signals that algorithm B sees for Group B. The test groups aren't truly isolated.
Exactly, TikTok uses shadow mode testing. They run algorithm variants in parallel but don't serve the results to users. They log what each variant would have recommended and simulate engagement based on historical patterns. Only after offline validation do they run live A/B tests.
That was intense. Maya, what separates candidates who understand TikTok's complexity from those who don't?
Understanding that TikTok isn't just Netflix with shorter videos. The real-time nature changes everything: recommendation latency, content moderation, viral detection, mobile-first constraints. Most candidates underestimate the engineering complexity of making everything feel instant.
The viral content problem was eye-opening. Traditional CDN strategies don't work when demand can spike 1000x in minutes. You need predictive caching and intelligent content placement.
The scale of the ML pipeline is insane. Billion users, real-time learning, sub 100 milliseconds inference. You can't just throw more hardware at it, you need fundamentally different architectures like Monolith.
What about the mobile-first constraints? How did that change your thinking?
Everything becomes harder. Limited storage, variable network conditions, battery constraints. You can't just optimize for throughput, you need to optimize for efficiency and user experience on crappy cellular connections.
And the content moderation complexity. Different rules for different countries, real-time enforcement, appeal processes. It's not just a technical problem, it's a legal and cultural problem that engineering has to solve.
The cost optimization strategies were fascinating too. Predictive encoding deletion, tiered storage, intelligent caching. At TikTok's scale, every optimization matters because it affects petabytes of data.
Let's break down the key technical innovations that make TikTok possible.
First, the Monolith framework for real-time machine learning. Traditional batch ML doesn't work when user preferences change every few swipes. You need online learning that updates models continuously as new data streams in.
The segment-based CDN caching is brilliant. Cache just the first 2 to 3 seconds of every video globally, then cache subsequent segments on demand. Instant startup with efficient storage utilization.
And the viral detection system, using velocity metrics, cross-platform signals, and engagement acceleration to predict viral content before it explodes, then rapid cache propagation to handle the spike.
Don't forget the encoding pipeline optimizations. GPU clusters for parallel processing, AI-driven format prioritization, predictive encoding deletion. Turning hours of processing into minutes while managing storage costs.
What mistakes do candidates typically make when designing TikTok?
Treating it like a traditional video platform, they focus on storage and delivery but miss the real-time recommendation complexity. TikTok is fundamentally a machine learning company that happens to serve videos.
Underestimating mobile constraints. Designing for desktop web first, then trying to adapt for mobile. TikTok was mobile first from day one. Every decision optimizes for smartphone users on cellular networks.
Not considering the global complexity. Different content laws, different network conditions, different user behaviors. You can't just deploy one system worldwide, you need regional adaptations.
How does TikTok's algorithm actually create addiction? What's the technical implementation behind the psychology?
It's variable ratio reinforcement implemented through machine learning. The algorithm learns your exact reward thresholds when you're about to get bored and delivers exactly the right content to keep you engaged. It's not accidental. It's engineered.
The technical implementation is terrifying when you think about it. Real-time analysis of microexpressions through front cameras, scroll velocity patterns, audio volume changes. The system knows you're losing interest before you do.
And the feedback loop gets tighter over time. More data means better predictions, means more engagement, means more data. It's a self-reinforcing system that gets more addictive the longer you use it.
What about the infrastructure costs? What does it actually cost to run TikTok?
ByteDance doesn't publish exact numbers, but industry estimates suggest $3.5 billion annually just for infrastructure. Bandwidth costs alone are probably $1 billion plus. Video storage and processing is incredibly expensive at this scale.
The encoding costs must be massive. 300 million uploads daily, each requiring 20-plus format variants, using GPU clusters for speed. That's probably $100 million plus annually just for video processing.
And the machine learning infrastructure, training recommendation models on billion-user datasets, real-time inference for every swipe. The compute costs for ML probably rival the video costs.
Looking forward, what are the biggest technical challenges TikTok faces?
Regulation and data sovereignty. Different countries wanting data stored locally, content moderation compliance, real-time transparency requirements. The technical complexity of supporting multiple regulatory frameworks simultaneously is enormous.
Competition and algorithm differentiation. As other platforms copy TikTok's approach, how do you maintain technical advantage? The next breakthrough might be multimodal AI, understanding video, audio, and text together for even better recommendations.
Scale sustainability. Growing from 1 billion to 3 billion users while maintaining sub-200 milliseconds latency globally. The infrastructure costs scale linearly, but the technical complexity scales exponentially.
Any final advice for engineers preparing for TikTok or similar system design interviews?
Focus on real-time constraints and mobile-first thinking. Don't just design a video platform, design a real-time, personalized, mobile-optimized recommendation engine that happens to serve videos. The ML and data pipeline complexity is the real challenge.
Understand the full stack implications. Every component affects every other component. CDN strategy affects recommendation latency, affects user engagement, affects content creation. Think holistically about the entire system.
Practice with real constraints and real numbers. Don't hand-wave the scale problems. Work through the math of processing billions of events, storing exabytes of data, serving millions of concurrent users. The numbers matter.
This has been incredible. We've seen how TikTok represents a fundamental shift in system design, from batch processing to real-time everything, from desktop first to mobile native, from content discovery to algorithmic addiction.
Thanks for having me. Building TikTok's infrastructure was the hardest engineering challenge I've ever worked on. The real-time ML, the global scale, the mobile constraints, it pushes every technology to its limits.
This was way more complex than I expected. The viral content handling, the cost optimizations, the moderation pipeline, there are so many non-obvious technical challenges.
The psychology-engineering intersection is fascinating and terrifying. TikTok proves that technical architecture can literally rewire human behavior patterns. That's unprecedented power and responsibility.
Until next time, remember that the most impactful systems aren't just technically impressive, they change how humans behave. TikTok's algorithm doesn't just recommend content, it shapes culture, attention spans, and entire generations. When you're designing systems, ask yourself, what human behaviors are you optimizing for?
And whether those optimizations serve users or just engagement metrics, there's a difference between building addictive systems and building beneficial ones. The technical capability exists for both, the choice is ours.
This has been Unstruct AI, where we explore the human cost of the technologies that shape our world. Today, we've seen how TikTok's technical innovations created the most engaging platform in history, and maybe the most psychologically manipulative. The same engineering brilliance that solves recommendation latency also exploits human dopamine systems. Technology is never neutral. Every system design choice is a choice about human behavior. Build responsibly.